press Enter. The Select Condition screen reappears. Select another condition to measure or press F1 to end the current run. If you selected to end the run, an information screen appears advising you to shut down the aircraft in accordance with the flight manual. Shut down the aircraft and press Enter to continue. The Review Prior Runs screen appears. The run number is shown, followed by the condition. Use the up and down arrows to view the various conditions measured within the run. Take this information and plot it on your charts to determine the corrections needed in accordance with the applicable maintenance manual. When corrections are complete, press the F3 key to continue with the next run, or press the F1 key to quit and store the job data. Press the main menu key on your analyzer, then select and enter the Miscellaneous Items subheading. Under Miscellaneous Items, select and enter Printer Setup. For detailed instructions on how to set up your specific printer, refer to the section in the Model 2020 User's Manual titled Printer Setup. After setting up the printer, press the main menu key. Connect the communications cable to the analyzer and the printer. Make sure the power is on for the printer. Select and enter the subheading that contains the information you'd like to print. From this screen, select and enter Manage Jobs. From this screen, select and enter the Print function. Select a job to print and press Enter. The analyzer screen indicates the status and when the printing is completed. Install the vibration sensor and applicable bracket for your installation in accordance with the maintenance manual or applicable balance chart. Attach the vibration cable to the sensor and wrap forward around tail boom toward the cabin. Rotate the tail rotor assembly to the vertical position. Install the photo tack and applicable bracket to the tail rotor gearbox and align the tack toward the tail rotor blade to be used as the target blade. Attach the tachometer cable to the photo tack and wrap forward around tail boom toward the cabin. To begin the tail rotor balance, first turn the analyzer on. Use the up and down arrows to navigate the screen until the selection Tail Rotor Balance is highlighted. Press Enter. The screen will display the Tail Rotor Balance banner across the top. Select Start a Job by using the up and down arrows and then press Enter. The Tail Rotor Setup screen appears. Default values in some fields appear automatically, but can be changed to more appropriate data. Enter the name of the aircraft by using the analyzer keypad. Use the down arrow to progress to the next field, Sensor Channel. Note that this entry box has pointed ends. The information for the pointed end boxes cannot be entered from the alphanumeric keys. Instead, use the right and left arrows to navigate and choose the appropriate selection for which channel the analyzer will use to measure and display tail rotor vibration. Sensor type is selected from the list of applicable sensors. Use the right and left arrows to navigate and choose the correct sensor. Tack channel corresponds to the tack input port from the once per rev source used for balance. Tack type gives you 5 options to choose from. Use the right and left arrows to pick the appropriate option. For tail rotors, optical is the most common. For tack position, enter the clock position of the photo tack as viewed from where you would stand as if using a strobe light to acquire clock angle. For balancing RPM, use the keypad to input the tail rotor RPM expected when balancing. Rotor direction is the tail rotor direction of the rotation as viewed from your position, as if using a strobe light to acquire clock angle. Toggle and choose between clockwise and counterclockwise. For blades, use the right and left arrows to navigate and select the number appropriate for the tail rotor system. After all fields are completed, press the Enter key. A screen appears asking if you'd like to store this new setup. Press F1 to accept and store the setup. The customer information screen appears. Entering this information is optional, but providing a customer name is recommended, as it will aid in identification of the job for resuming or reviewing purposes at a later date. When completed, press Enter. The tail rotor equipment setup screen appears. This screen directs you to install and connect the tach and vibration sensors you specified in the setup. Attach the tachometer cable to the channel specified in your setup. Attach the vibration cable to the channel specified in your setup. Examine the bottom of the tail rotor equipment setup screen. You will see the Tach On option. Press the F1 key to activate this option. Thoroughly clean the area on the target plate where you intend to place the reflective tape. With the tape backing still in place, hold about a 3-inch strip of reflective tape in position on the target plate in front of the phototach. Move the rotor assembly back and forth to ensure the red LED gate indicator light on the back end of the tach turns on and off as the tape crosses the beam. Then, flap the rotor assembly to verify beam contact through full tail rotor motion. Note the position of the tape on the target blade. Remove the backing and apply the tape firmly and smoothly to that location. With the equipment setup complete, return to the analyzer and press Enter. The Start Aircraft screen appears. Start the engine in accordance with the airframe flight manual and set the tail rotor RPM as specified in the tail rotor job setup. When RPM is set to the desired level and stable, press Enter. The analyzer now displays vibration data. The current and averaged RPM frequency, IPS, and clock angle are displayed along with a percentage error in averaging indicator. When the percentage error reaches its lowest point, press the Enter key. An information screen appears advising you to shut down the aircraft in accordance with the aircraft flight manual. Shut down the aircraft and press Enter to continue. The Review Prior Run screen appears. Take the current run data and plot it on the applicable balance chart for corrections. When corrections are complete, you can proceed with the next run by pressing Enter or F3. To end the current run, press F1. To print a report, follow the same procedure used for the main rotor. Using spectral analysis allows you to complete and store surveys using the setup feature. Several different components can be surveyed without manually entering the setup data between surveys. To begin, press Main Menu on your analyzer. Select and enter Vibration Spectrum Surveys. From this screen, select Start a Job. The Spectra Setup screen appears. Default values in some fields appear automatically, but can be changed to more appropriate data. Although Name is an optional field, it's best to name each setup to differentiate it from other spectra you'll store in the future. Determine and enter the minimum and maximum frequency requirements. For pointed end boxes, use the left and right arrows to navigate between selections. Choose either RPM or Hertz for your frequency units. Select and set the resolution field. 400 lines is adequate for most applications. For average type, navigate and choose between normal and peak. Blocks in average refers to the number of data blocks you want used in the calculations. Higher numbers provide more reliable data but require more time. Measure inputs determines from which channels the vibration data is acquired. Navigate among A, B, or A and B. Enter a defining name in Channel A description and Channel B description as necessary. Select and set the vibration field to the appropriate type of units for display on the amplitude or Y-axis. Mod is an abbreviation for the unit modifier relevant to the unit specified. Navigate and choose the most appropriate selection. Full-scale vibration indicates the maximum amplitude you expect to encounter. Navigate and choose the selection that displays the full amplitude. Select among the choices in the sensor field until the desired sensor is displayed. Refer to your owner's manual to add additional sensors to this list. Press Enter. A screen appears asking if you'd like to store this new setup. Press F1 to accept and store the setup. The customer information screen appears. Entering this information is optional, but providing a customer name is recommended. as it will aid in identification of the job for resuming or reviewing purposes at a later date. Start the component you are checking and let it achieve normal operating conditions. Press Enter to begin acquiring data. When the spectra is displayed, observe the 3 boxes at the bottom of the screen. The first box, Options, corresponds to the F1 key. Press the F1 key and the boxes change to read Cursor, X scale, and Y scale. Press the F1 key again and the boxes change to Normal, Harmonic, and None. Press either the left or right arrow keys to produce a normal cursor, as well as an X and Y value readout box. Move the cursor along the X axis using the right and left arrow keys. The value of both axes are displayed in the readout boxes according to the current position of the cursor. Press the F1 key twice, and then choose the key corresponding to harmonic, the F2 key. Multiple harmonic cursors appear to the right of the fundamental frequency. When the fundamental frequency cursor is moved, the multiple cursors automatically follow the movement and position at the new multiple. Press the F1 key twice, then the F3 key, and the 3 boxes return to the original names. Press the F1 key for Options, then the F2 key for X scale. The boxes change to read Expand, Default, and Shrink. Press the F1 key corresponding to Expand, and the X scale of the spectra enlarges. The 3 boxes at the bottom of the screen automatically revert to the original 3 choices: Options, Pause, and Restart. Press the F1 key, then access the X scale by pressing F2. Press the F3 key corresponding to Shrink, and the X scale of the spectra is reduced. The 3 boxes at the bottom of the screen automatically revert to the original 3 choices: Options, Pause, and Restart. Press the F1 key, then access the X scale by pressing F2. Access the default setting by pressing the F2 key again, and the analyzer returns the X and Y scales to the values specified in the setup. The 3 boxes at the bottom of the screen automatically revert to the original 3 choices: Options, Pause, and Restart. Press the F1 key, then press the key corresponding to the Y scale, F3. Here you can perform the Expand, Default, and Shrink functions for the Y-axis in the same manner. After finishing, choose the key corresponding to Pause, F2. Pressing the key stops data acquisition and freezes the screen with the latest displayed data. Press the key corresponding to Resume, which is F3. The Model 2020 will acquire additional data. Anytime the spectrum is displayed on the screen, you may press Enter to terminate data acquisition. To print your vibration spectrum surveys, follow the same procedure for printing balance reports. Spectral analysis can seem intimidating at first, but it isn't difficult once you understand the basic concepts. ACES Systems offers extensive training on spectral analysis as well as other applications to help you use this versatile equipment to your best advantage. Please contact us if you have questions or would like information on additional training. At ACES Systems, our goal is to provide you with the equipment and the knowledge to quickly and efficiently analyze, balance, and monitor aircraft performance. The ability to observe and quantify engine vibration and noise levels allows you to trend engine performance, resulting in the safest, smoothest flight possible and prolonging the life of the aircraft. The Model 2020 Probalancer Analyzer allows you to maintain your aircraft at optimum levels. And that's why we're here, to create better aviation maintenance solutions for you. ACES Systems.